So our topic gave us these squares, this problem, and our task was to produce a function that would explain this pattern of inputting stages and receiving an output in squares. So for example, stage 1 would equal 2 unit squares, and stage 2 would equal 6 unit squares. And it keeps going on. As I said, it's just a simple input-output function where the input is the number of stages and the output is the number of unit squares. So the answer that we found is f of x equals x squared plus x, and I'll show you in a minute how it lines up with all the examples I just showed you. And it's a quadratic function, so it's in standard form a squared plus bx plus c, and as I said previously, x represents the stage number. So here's the proof. So f of 1 equals 1 squared plus 1, and you get 2, and so on, just like the first slide. And here's a few more examples going all the way up to 21 stages, which yields 462 unit squares. And here's a graph example of our function, where the domain is restricted and the range is set at 0, infinity. Now for the experimental questions. So a question that could be solved algebraically using this function is if you just gave a value for f of x, 20 for example, and then said solve for x. So in this case, if f of x equaled 20, then x would equal 4, as you just use a simple guess and check. 4 squared plus 4 equals 20, 16 plus 4 equals 20, and then 20 equals 20. And so here you have to remember that since it's a quadratic function, it has two solutions. So you would repeat steps 1 through 3 using the guess and check again. And this time it's a little more complicated, but it's just about as easy. It's negative 5 squared plus negative 5, which also equals 20. So your answers are x equals 4 and x equals negative 5. Now for a graphically solved experimental question. So our question is, what points would the function x squared plus x equals 20 yield on a graph? So you already have the answer at your fingertips. You already have x and f of x values. So it's just a matter of plotting the points. So you have 4, negative 5 is x's, and both y's will be 20 since they're just on opposite sides of the y-axis. It's a quadratic function. So there are the points graphed. Yep, so that's our function. Thanks for listening, guys, and hope you enjoyed.